Hello everyone and welcome to a new video. In this video we will discuss the concept of nested F statements. So nested F statements. So in programming we have the option to have F statements inside each other. So for example, I could have an F statement with its end, and then completely inside this, which means really really means nested, there is another F statement with its end, and in principle I could have as many F statements nested inside each other as I wish. So for example, I could have yet another one, so if, and another end here, and I can keep going. So nesting could be useful sometimes. But if it is possible to avoid it, then please let's avoid it. Why? The reason why it's recommended to avoid it is because it's difficult to debug if there is an issue. It's much better to have, if it is possible, of course, to have a single F statement with multiple else Fs rather than nesting. But sometimes it's really more convenient to do nesting, and because of this we will have to study it. So let's actually take an example. Suppose we have a function with multiple branches. Let's say f of x equals, suppose it equals -1, where x is greater than, where x is less than -1. It equals x squared when x is between -1 and 3, and it equals 9 when x is greater than 3. So you see, one thing to notice about this function is that its branches are mutually exclusive. Of course, it's a continuous function. In fact, let's draw it just to convince you about this. This is the y-axis, the x-axis, and let's mark the points -1 and 3. Let's put here also 1 and 9, right? As much as possible we are trying to sketch this to scale. And now let's sketch the graph of the function itself. So it is constant up to -1, and the constant equals 1, and then it has a parabola. It becomes a parabola and then goes all the way to the value of y equal 9 at x equal 3, and then after that continues as a constant function. So it's a continuous one. However, the branches, if you think about the branches, so the first branch excludes, so let's think about the first branch, it excludes the 1 and then occupies the rest of the x-axis from -1 to -infinity, excluding -1 itself. Also, the second branch includes -1 and goes to 3, inclusive of course, and then finally the last branch, if you think about it, it starts from 3, but it doesn't include 3 itself, and goes all the way to infinity. So this is the branched function that we have in this example. And what is needed is that we write a code using F statements that calculates the value of f of x given x. So let's actually write this here. Suppose x equal input, enter x, and then there is an F statement. If x is less than -1, then the conclusion is that f equals -1. Equal 1. I actually made a mistake here in the write-up. It actually equals 1. And then else f x. So let's see, let's write it carefully. X is greater than or equal -1, and x is less than or equal 3, right? For readability, we can put these, can leave these spaces. By the way, I cannot leave a space here. Then in this case, f is equal to x squared, And finally, and that I can write using else, the function f just equals 9. And there is an end here. Let's actually test this. And maybe to make the test work, we need to display the value of f. So let's run. All right, so it runs. Let's enter, for example, -5. It gives us 1. Let's try to run it again and enter a value of 0. Gives us 0 as expected. And finally, let's enter, for example, 21. The answer should be, of course, 9. So the answer is 9. So the code works. So what you have here is just a single f statement. But suppose someone is willing to write it in the form of nested f statements. And for that purpose, I will actually comment this out and see what we can do. Let's see. I can write the following. If x is less than -1, then the value of the function f is 1, and there is an else, and there is an end. Okay, that's one f statement. And that basically, if you think about it, it covers this part, right? It covers this part completely. Now, the else now will cover the other two parts, and I can have a separate f statement with an end. So there will be a separate f and a separate end. In this f, I will say, let's see, if the value of x is less than or equal -3. Okay, so what should I do? Then the value of the function f is, it's equal to x squared. All right, and else, so otherwise, now we can bring the last f statement. So sorry, there is an x squared here. The last f statement. So there is f. If you see in the second f statement, I actually covered automatically this part, the second part of the x-axis. And by the way, I don't need to write and x is greater than -1. The reason is once you pass this part, automatically means that x is greater than or equal to -1. Okay, so there is a final f statement, which is basically if the value of the function, if it is greater than 3, and there is an end here, I can write f equals, the last thing is 9. Okay, and as you see, there is the nesting here. So there is this f statement, which is inside this f statement, which is inside this f statement. So you see you have 3 layers of f statements. Let's actually test this and make sure it does work as in the previous example. So let's see, clear. This is called simple nested f statements. Suppose I have -7, the answer should be 1. That works. Suppose I have 2, the answer should be 4. No, there is a mistake here. Why it's not calculating this correctly? So let me clear. So if x equals 2, the answer should be x squared, so it should be 4. So let's hit enter. Oh, there is a problem. So why this part is not working? So if x is less than -1, then that's the value. And then if else, if x is less than, oh, sorry, not -3, I made a mistake here, it's 3. So yes, thank you that we managed to debug this together, guys. So that actually the problem, it is it is 3, not -3. So let's actually run this again. Let me enter 2. The answer should be 4. So yes, that works. And maybe to suppress writing x, I can put a semicolon here. Let's do our final test, and let's enter a big number. Let's say 40. The answer should be 9, and it works. Okay. So this nesting is actually equivalent to the single F statement. But as you can see, it's much more difficult, even for the eye, to read it, because of the multiple layers on top of each other. There is one way, and let me conclude by this recommendation here. There is one recommendation here. If, let's choose a better color for this, if the conditions are mutually exclusive, then it is recommended to avoid nesting. And just to explain this briefly, if you notice, if we go back, the conditions, which is basically in this case the ranges of x, are actually mutually exclusive, which means the condition, which is the white color here, doesn't intersect the red color here, does not intersect the green color here. Okay, so these are mutually exclusive, right? There is no intersection between them. So if the conditions are mutually exclusive, it's actually better to avoid nesting and just write a single F statement, and every condition will have else F, and the last condition will have else. Okay, and otherwise, if things are not mutually exclusive, then you probably need to do some nesting. All right, so thank you so much, and see you in another video.